Okay, and I'm going to switch the input. Excellent. And I'm going to grab my ruler and my protractor and my pencil, and I am going to get ready to draw this first ray. And I'm actually going to draw all 3 rays on one picture. On the PowerPoint, it has 3 different pictures for each ray, but these are the 3 rays that you discovered yesterday. So I think we can put them all on the one picture. So the first one, and I'm going to put this right here. So I'm going to draw my picture. So I'm getting my principal axis, right? And I'm using the protractor as the curved mirror again on the 90. We'll put it right there. And again, I'm not looking over top, so I hope I don't make too many mistakes on it. I'll put the dull side on there. I've already told you that the diameter of this protractor, right, is 10 centimeters, which means the R is going to be what? That's the diameter of the protractor. We don't have a special spot out here at diameter. So if I want the center, how far am I measuring? Yep, 5. And the F, you can put it in as well, 2.5. So that's why I picked those numbers a moment ago. So right here, I'm quickly putting the C, and 2.5 in from there, I'm going to put the F. All right, okay? Rule number 1, a ray that comes in parallel to the principal axis, so I'm going to use one of these nice lines here. So if I have a ray that comes in there, rule number 1, where's it going to go? Yep.
Doesn't it go through F?
It does go through F. Nice. So now I want to draw a line. I need 2 points for that line. 1 point is the point at which it strikes the mirror. So that's where my ruler goes. The other point is where the F touches the principal axis. So you'll notice I put a little mark up here, but I'm dealing with this right here. And I'm going to run that along there. And I'm going to put an arrow out. And that's rule number 1. A ray parallel to PA will reflect through, where? Through F, right? So you're finishing that statement. You might have already finished it already. Excellent. All right? And I'm just clicking ahead here so I can see what my next one is. Okay, so next, number 2. A ray that goes through F will emerge. That says emerge, by the way. That's why you must listen as well as write in this class. How's it going to emerge? Yep, Marissa? Parallel to the principal axis. Geometric optics, which is what we're doing right here, this is called geometric optics, is reversible. If a light ray does one thing in one direction, you can switch the direction of the light ray around, and it will do the exact same except in reverse. Light is a reversible thing. So I could just change the arrows on here, but that wouldn't be any fun. Let me just take one that comes in here from the top. So I'm just coming from any direction, and I'm going to have it go through F. There it goes. A ray that goes through F will now emerge parallel, so I need to kind of line this up as best I can so it comes out parallel to the principal axis. And I'm going to call that number 2. And is my line parallel? Not bad. That's why I like using the graph paper, because I can see if I'm parallel or not. Okay? So it will reflect parallel to the principal axis. Oh, will emerge parallel, oops, to the PA. Parallel to the PA. All right? Number 3. A ray that goes through C will Well, let's do that. Let's pick a ray that goes through C. And I'm just going to pick one that's kind of up here on an angle. Right, so here I've got the ruler on C, and I'm just going to have it hit the mirror somewhere. In a moment, we're going to decide on how we know which way to pick them, and I'll talk about that in a minute. So this guy is going to come in and hit. What happens to that guy through C? Yeah, Megan? Yeah, reflects back on itself. Reflects back on itself. Okay, reflects back on itself. All right? So if it goes through C, it reflects back on itself. All right? Now, let's, oh, and I'm just looking at the PowerPoint here. Let's now practice drawing some ray diagrams. So, I've already shown you these mirrors. And we've already played the little game of can you spot yourself and can you see that, you know, right now you should be inverted, right? Everybody inverted out there? Lots of inverted people. And if I bring my hand really close, you can see there that it isn't inverted and it's really big. So what we're talking about now is, can we locate images in curved mirrors? We learned to locate images in plane mirrors. They're not very exciting, but that's when we had the arrow, the object, and we had how many rays? How many rays were important in locating this stuff? Yeah, 2 rays. And we had them hit, and we looked at where they appeared to cross. And that's where the image was found. The image is found where the light rays appear to cross. We're going to do the exact same thing, except now we're going to deal with curved mirrors. Now you might think, oh my goodness, with plane mirrors we had to use protractors, we had to find angles, and we had to do all this type of stuff. We could do the same with the curved mirrors, but that would be a lot of work. But we have just learnt 3 rules on where rays go without having to get a protractor out. So I can, instead of using a protractor to determine where the rays go, I can use these rules to determine where rays go. And then if I can find where they cross, again I can find where the image is. So, new piece of paper, and if you guys are continuing your note, you can work down. All right? And I'm going to just call this finding images in curved mirrors. All right? Finding images in curved mirrors. The first one we're going to do is concave. Actually, underneath it, subtitle. We simply call these, that's not a B, that's supposed to be an R, ray diagrams. So, ray diagrams, not Bay diagrams, ray diagrams. All right? So we call these ray diagrams. And first we're going to talk about concave. All right? So we need to set up another mirror situation. I'm hoping that we're getting good at it. Because we're using the same protractor, everything's the same. We're going to draw a line. Out at 5, we're going to put a C. Out at 2.5, we're going to put an F. We're going to put the curve. And then I'm going to tell you what to do. So I'm going to do the same thing here. And I'm going to use the protractor to put my nice curve. And I put the back side. And I'm going to put that there. And there's C. And again, halfway, 2.5. Oh, the nice thing about the grid paper is it seems to be landing nicely on spots there. All right, okay. And we're going to start with now an object. Yep.
Does it matter if the concave mirror is close to the edge of that?
You mean like close over here to this side of the world?
Close to the other side of the mirror.
If you have it over here, you're going to run into trouble. I do need it open on this side of the page. That's okay. Yeah. Connor, you need someone's look for you. Okay. Because I'm going to be drawing things out in this area here. It's the convex that we have to watch for. All right? Okay. just like when we were locating images in a plane mirror, we're going to use an arrow as an object because arrows are nice and simple to draw. This time I'm not going to get too creative and put my arrow on an angle. I'm just going to put an arrow out in front that's straight up and down. Now, the location of your arrow to start with is going to be somewhere beyond C. And it really doesn't matter how far. Our pictures will be about the same. It doesn't matter how far we put that arrow beyond C, and I'll put one there. Don't make it too big. Let me show you. Let me unlock the door here. Boy, my movie's going to be exciting today. I had visitors, and it's going to be fun. Okay, so I'm going to make an arrow, and I'm going to make mine 2 squares tall, just because I'm dealing with squares. It's going to look like that. I'm going to put the arrow on the top. Okay. Yours is bigger than that? Well, if you make it too big, then the rays won't hit the mirror. And if they don't hit the mirror, it's no fun. So I try to make it like half the height of where I stopped my curve on my mirror. Okay? And now we need to locate the top of the arrow. So, just like before, there's light coming in. It's hitting the arrow. Just like your face out there. Because right now, your face, trust me, is beyond C. You're way out beyond C. There's light hitting your face. The light hits the mirror, bounces off, and heads back towards you. And we want to find that image that you can see when you look in the mirror. That's what we're doing. How many rays do I need to locate this thing? 2. So let's take the first rule. A ray that comes off of the top of the mirror, or the top of the object, and it's parallel to the principal axis. Where's it going to go? Through F. And make the ray kind of longish, because we're not sure where it's going to overlap. All right? And we want arrows in, arrows out. Oh, one thing, I want you to put here O over top of that arrow. What does that stand for? Object. And we're looking for the image. Let's try a second ray. Actually, how many rules do I have? 3. How many am I going to need to use? Only 2. So we could use any of the other rules. I like rule number 2, so we're going to use number 2. A ray that goes through C. Sorry, it's wrong. That's not rule number 2. A ray that goes through F. How does it come out? Parallel. So now I got to line it up. And this is the tricky thing about that second rule. It's going to come out parallel. Oh, and look at mine's not perfectly parallel. See how it's kind of trailing away here? Oh, terrible. Our eyes and our brains will locate an image that comes from a mirror by finding where the reflected rays cross. Do the reflected rays cross? Yeah. They cross right here. The reflected ray, I put the arrow right on the spot. I didn't mean to. There, I'll put another arrow. Right there. That spot right there is the head of the arrow. All right? Now, when we did plane mirrors, we didn't have a principal axis. We found where the top of the arrow was, and we found where the bottom of the arrow was, and then we said, that's where the arrow is. Because the arrow is on the principal axis, not all rays, but a ray coming from it is going to hit the mirror and come straight back. The base of the arrow, or the base of the image, will always be on the principal axis. So we're not going to use 2 rays to locate the base. We're going to assume that the base is right there in that position. That makes the head of the arrow down here and the base of the arrow up there, and that means my arrow looks like this. I'm going to say that again, a little slower. I used 2 rays using our rules to find where they crossed, the rays that were reflected, and that located the tip of my arrow. The base of the arrow is on the principal axis. I can't use any of my rules because C and F are right on the principal axis. But if I used angle I equals angle R, I could do some reflections. But in the end, this base would be located on the principal axis every time. That's why we choose to draw our ray diagrams this way. So really all we're looking for is the location of the tip of the arrow, and then we will make the arrow's base be on the principal axis. By doing that, that forces my arrow to be upside down. All right? And that's going to be the case for all of our pictures. Now we can do salt. Oh, actually, I don't write it like that. Let's do it like this. Let's write salt. S-A-L-T. Salt. Because now we have an image. What's the size of my arrow compared to, or what's the size of my image arrow? I've just put an I there. Compared to the size of my object arrow. Yeah, smaller. I heard some whispering out there. Smaller. That's correct. It's that simple. Smaller. All right? What's the attitude compared to the object? Yep. Inverted. What's the location? Now, you're going to do it with respect to the mirror and also with respect to parts of the mirror that we know what the names are. So, how would you describe the position or the location of that image? Just describe it to me. If I couldn't see what you were doing, and you were describing it to me, say, over the phone, or you were texting each other, who knows what you're doing? The answers? Cheaters. How would you describe that? Where is this thing? Yep. Now, it may not be exactly halfway, but between C and F is good enough for me. Between C and F. All right? And what type is it? Well, is it located in the imaginary virtual world of a mirror? Or is it located out in the real world? Where's the shiny part of my mirror? There's the shiny part. This is the dull part. It's located out in front. It's located out in front of the mirror, just like the object is. That's out in real space. For mirrors, that's real space. In behind, that's virtual space. We can't live in the virtual space of a mirror. We can't actually access that. You can't step inside of a mirror. I've said that a couple times. Nobody laughs because you're all going, I still don't get this. Quit making the joke about being in the virtual part of the mirror. In behind a mirror, the virtual world. Out in front of the mirror, that's where us real people live. The virtual people live in the mirror. Jillian's got a look on her face. Okay, all right. Oh, okay. That's I'm exhausted looking face. So what type is this? Even my little speech isn't enough? Megan, real. It's a real image. Awesome. All right, I'm going to do one more for you. And then actually there's a sheet where I want you to complete the rest of them. If you've printed the sheet, you can actually get the sheet out now and you can do the second picture on the sheet because I've done the first picture with you. If you don't have the sheet, you can keep drawing them this way. Just draw them on paper. You don't have to have the sheet for this, okay? So if you've got the sheet, you can get the sheet out. If you don't, you keep drawing with me on your note paper. It doesn't matter whether you have the sheet or you don't have it. It's got a whole bunch of curves. Hold it up if you've got it. Let me see. That's the guy. That's what we're looking. Oh, wait a minute. That's for convex, isn't it? Was there another one there? We want the one for concave right now. Concave one. Hold it up nice and high for everybody. See it? Good. You find it? Concave. Good. Good, good.
Are we handing it in?
No, this is practice. So you don't have to do it on special paper. It's not going to be handed in. Okay, so let me get set for the second one. It's the exact same picture, So in other words, if you're doing this and you're doing this not on the piece of paper, you just quickly get yourself set just like we did the last couple of times. I'm going to put that nicely on the line. There, beauty. Gonna put that out there like that. My mirror looks horrible there, but anyway, it's gonna get the point across. I'm gonna go out to 5 centimeters. Right there's my C. I'm gonna go to 2.5 centimeters. There's my F. And now I'm moving my object in. All right? So what I want to do is I want to cover all of the important spots. Last time, notice where my object was. Actually, I'm gonna make a little statement here on my last picture. The last picture, notice the object is beyond C. Object is beyond C, outside of C. And that's what we get as our characteristics of the image. This time, if you've got the paper, well, you tell me, where's the object for my second picture? Yep, right on C. So I'm gonna make my arrow right there, right at C. So if you're taking the note, the object is at C. Oh, I also wanted to prove to you that the third rule would have worked. It's okay. The third rule would have worked. You could still draw that third line on there, it would have worked. Anyway, let's not worry about that. Okay, how many rays do I need? 2. Notice I can't use the third rule in this case because if I were to put a ray through C from the top of the arrow, it would do that and it would never hit the mirror. So I can't use the third rule for this one anyway. You go ahead if you know what you're doing. Use pencil, right? A ray that comes in parallel goes through F. A ray that goes through F comes out parallel. And again, extend them to the point where they cross, because it's all about crossing. Oh, and mine sucks.
I always put my arrow where it crosses through and that. I don't even know
Excellent. I love the frustration. She could have kept that in her mind, but I like that she verbalized it. It's beautiful. That's all right. I did mine terribly. This is horrific, and I plan on putting this on the internet. We all know that Mr. Sanders' ray diagrams suck. Because this image, this crossing point, should land perfectly at a certain location. Any ideas where that should have ended up? At C. It should have ended up at C. I think my ray down here, right there, my first ray, I think doesn't cut across. Look at both of my rays appear to be below my principal axis. I screwed it up. It should be at C. Don't sweat if it's not. It means something isn't perfectly parallel. It means it didn't cross perfectly. That's very hard to do. I'm going to draw mine like this. Like that. Right there. And it should have been at C. Right there. Mine's a little bit of a screw up. It should have been there. Because we've got some very similar triangles here if we drew it up nicely. And I didn't. Did anybody get it at C? Anyone successfully? No, not even close? That's unfortunate. Close? That's good. That's good. Close is good. Salt.
If it's not on C,
Don't worry about it. We're still going to describe the location that way. Because I want you to know what the proper thing is. What size do you think this thing is? We got O, I. Size of the image compared to the object. Yeah, it's supposed to be the same. Attitude. Yep. Inverted. Location. Yep. At C. And what type is this? Yep. Real. I'm taking the same person, whoever puts the hand up. This is pretty straightforward stuff. It's out in front of the mirror. It's a real image. That means that this image should be able to be projected onto a screen. And I'm going to show you that later on. With these big mirrors, I can actually project these real images onto screens. All right? Now, at this point, for those of you Are you okay, Abby? You think you're okay? What is it that you don't like? The real? You don't like the fact that in front of a mirror is the real world and in behind of the mirror is a virtual world?
Like, putting it onto the screen.
Oh, yeah, I'll talk about that. I'll show you later. Just wait for a minute. Jeepers, you guys are in such a hurry. So, if you've got the page in front of you, keep going, right down to the bottom, all right? If you don't have the page in front of you, this is what you're going to need to draw. You're going to need to, and I'm just going to sketch this. You're going to have C and F, and I want one picture with the arrow in between, all right? And then you're going to do another one, and you're going to have C and F, and you're going to have the arrow right on F, and I'll say right here, asterisk, 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 hard one, all right? So you're gonna have trick. You're gonna be stuck with that one. It's gonna be tricky, because remember, you've got to find where the rays that come out cross, and then the last picture, C, F. I want it inside here. All right. I want it in between the C and the F. Follow the rules. So with this last one, you may have to go back here like this, right? Something like this, backwards to see where it hits and have it come out parallel. This one here, tricky one too, tricky one. So see if you can do that. And then do the salt for all of them. Salt, salt. All right? Okay? And work on that, and then I'm gonna stop doing some recording here, and then I'm gonna restart for later on.